Hello, everyone, and thank you for being here. And I hope you are enjoying as much as I am this conference. So my name, as Mary says, Maria. I work for ThoughtWorks. We are a global software consultancy, and I'm going to talk to you about observable microservices. But before I do that, let me show you a picture. This is a picture of a place in New Zealand. So another person that went to New Zealand. I went here last December with my boyfriend, and we did like a lot of hiking and stuff. New Zealand is an amazing country, and I think everyone should go there at least once. And one of the amazing things about New Zealand is that it's where the Lord of the Rings and the Hobbit trilogies were filmed. And this picture over here is actually in the Tongariro National Park in the North Island. That's when Mordor is located. So we actually spend the night in Mordor. Like, that is really cool. And you look at Mordor, it's this really dark place where like our friends Frodo and Sam go to destroy the ring. And they face like a lot of challenges, like, there are orcs all over the place that try to kill them. They have Gollum, who wants to steal the ring from them. They have a really big spider who tried to eat them at some point. And there is obviously Sauron, who just want the ring back to dominate the world and whatever. So, it's a pretty hostile environment. And as I was preparing for this presentation, I thought, there's another environment that us as developers face almost every day that is really hostile too, and that's production, right? So production is a really hostile environment. You've got like bugs, you've got security breaches, you've got servers that overload, and just weird behavior that you haven't seen anywhere else. So that's production. And in the good old days of the monolith, you have a handful of applications maybe that you need to maintain in production. So you kind of went by, have your little tricks to like monitor those systems and make sure that they were okay. But now we are in the land of distributed computing. So our problems just got multiplied by 10 or by 100. So it's a much more complex situation. So a lot of the techniques that we use for a monolith are just either not applicable for microservices, or they need to be rethink, and we need to just get better at them. And this is what this talk is about. It's about what those techniques and practices I think that they should be. And I'm going to go around 3 topics. They are discovery, monitoring, and debugging. So let's start with the first one, discovery. So, we have our client. So this is it can be an application, it can be another service that is a client. So, and it's requesting some information from a service, right? And in this scenario, the service has a well-known IP, and it's a static IP. So, my client knows where he finds it, where he needs to find it. But that's not always the case. Sometimes you might be in the cloud, and you might have some dynamics IPs. So, that service might not always have the same one. Or you might want to take advantage of one of the good things about microservices, which is scalability. And you might want to, scale up that service. So now you have 3 or whatever instances of that service, and your client needs to decide which one it needs to go and call to get that information that it needs. So this is a fairly common pattern, or a fairly common problem that has a fairly common solution, and it's the service discovery pattern. And that can be applied like 2 ways. One of them, you basically have a router, which normally is a load balancer, and that load balancer will call something called a service registry, which is basically where your services will go and say, hey, this is where I live, and these are my instances. And so the router will query that service registry, will get all the IPs, and then it will do the load balancing stuff to figure out which service to call. And this is called server-side discovery. There is also another one, which is the client-side discovery. It basically means that the client will directly call the service registry to get that information, and then just go and find where it needs to, what is the service or the instance of the service that it needs to call. This is the client-side discovery. which is something that a lot of the frameworks that we normally use for microservices, like Spring Boot, are starting to help us with. Spring Boot has a module or a library or whatever you want to call it that really allow you to do this in a really easy way. So it's a lot of what works for you, which one of the two you will prefer. What is important is the concept of the service registry. And this is, as I said before, a place where you can store every service, where it's located, what are the instances that we have. And it can be really simply a static file, or it can be something a bit more complex, like a distributed data store, or even a console, which not only allows you to do service discovery and service registry, but it will also give you some kind of configuration management too. So the next thing is monitoring. And monitoring is important because we need to know what's going on in production. We need to be aware on how our systems and our applications and our services are behaving. And again, when you have just one application, that kind of was easy, or well, not easy, but it was manageable. You could code to the host, you could like extract the logs and work from there. But when you have like, multiple services or multiple systems, that they are also different technologies, different stacks, things start to get a bit fussy and difficult. So there are a lot of things that we can do, and I'm going to share with you a few of them. A really good place to start is to stop having all of these logs all around the place and have them in one single place, like aggregate them in one thing. That's a really simple step. And you can use something like the Elk stack that is really popular, and it will allow you to do that. One thing to remember here is that before you actually start aggregating things, make sure that you have a conversation with everyone when you actually kind of agree on what is the format of that log, and have some consistency across the board. Because you can have them all aggregated in one place, but if everyone decides to do logs in a different way, it's going to be really difficult for you to go through all those logs and search information that is useful. So that's one thing, which I say is fairly easy. There's another one, there's metrics. You might want to not just see how the servers are behaving, but how our services are functioning, and what are some of the metrics that will tell you whether they're functioning or not. Again, the micro frameworks or microservices chassis, I don't know, whatever is that the framework that you're using to build microservices, will also give you something really simple where you can either set up a metrics endpoint, or you can just have it for free, or out of the box. And the idea is the same thing: aggregate all of that stuff, and then send it to a place where you can then review, view, and look for patterns, whatever that is. That can be, this one is the dashboard that Prometheus gives you, but you can use Graphite, whatever works for you, basically. And then you can even go a bit further and also add to that monitoring all your health checks and how healthy your services are. Those endpoints, I'm pretty sure everyone has heard of health checks, but basically they just assess the health of your system or your service. They are really simple ones, which just go and say, hey, is this application running? And they might just do a ping to that IP and that port. They might be enough for some cases, but in other cases that might not be sufficient. In some cases you might have other dependencies, like a database or an FTP folder that you need to access, or that the service needs to access. So it is important that your health checks also look for the healthiness of all the other dependencies that your service has. And yeah, aggregate them also. And the last thing that I think we need to monitor is something called, we want to use something called synthetic or semantic monitoring. So all of the things that we talked until now were around individual services and the data that we can get, or the data that these services will give us. So that's how we made them observable, right? We can observe them and they will give us information that we need. But your applications or your system as a whole will be will be formed by different services talking to each other. So a business flow or a user journey will span multiple services, right? So we want to also make sure that that journey is working as expected and it is working within the times that we have stipulated, that they are right, and all that stuff. So synthetic or semantic monitoring kind of look into that. It tells you that you already have user journey flows or application level tests or whatever you want to call them that you run against your staging environment. And if you are doing continuous delivery, you will run those tests in every commit, or at least every time you go to do a release or whatever, every so often. So why don't you take a subset of them that are representative of the functionality that your application has and run them against production? And then share those details in your monitoring dashboard or whatever monitoring tool that you're using. So that way you will have one, you will highlight any possible errors that otherwise they might have gone unnoticed because you didn't have a way of monitoring the whole flow. And the other thing is that it will also allow you to see patterns. So like, hey, the response time for this flow was, that much a month ago, now has gone up by X%. So maybe there is something that I need to look and see what's going on in there. And now that you have all of this information in a centralized place, or at least in some kind of tool that allow you to see and look and spot patterns, then the next thing that you want to do is actually just start creating alerts that tell you, hey, I have all of this information. I can now tell you when something failed or when something is not right. And alerts are really good, but there is also a thing with them, and it's that they can get really noisy. You can get a lot of alerts, and it's really difficult sometimes to differentiate when an alert is something important to when an alert is just something that you shouldn't pay as much attention or something important. So start also thinking of how to create smarter alerts. And that's something that you won't get it right the first time. It will be kind of an evolution, and that's okay, that's perfectly fine. Because you will be smarter than the next week as you are today, so that's cool. But your alerts, you might have a different type of alert. For example, if your service or one of your services is giving you a 500 once, that's this service is giving you a 500 in every single request for the last half an hour, right? So there might be different type of alerts. So that's also really important. And kind of the last thing that I want to talk to you about is debugging. So we've been making sure that we can keep track of our microservices with service discovery and support, scalability also. We make sure that we have all the information in the world for monitoring, and we also have alerts that tell us when something is wrong. And all of this has been in preparation for when the moment will happen that you will find a bug in production, there will be an issue that needs to be fixed, and you will need to debug your production systems. And in a monolith or in a non-distributed application, that's kind of easier. You can have the stack trace, and you can kind of go through the stack trace and see where that thing happened. But in microservices, you might have a request that has spanned multiple services. So it might be pretty tricky to understand where that error was originated. So there's a simple thing that we can do that can help us a lot with this, and is add correlation IDs. And a correlation ID is just an ID that you tie your request when it enters the system. And it's that unique identifier that it will follow the request to wherever it goes. And it can be used for a lot of things, but for debugging is extremely useful because, as I said before, it will allow you to understand where that request got initiated, and hopefully you will be able to find the root of the problem. Oof. So we have reached the end of the talk, but before I go, I would like to just sum up what I just said. We talk about discovery, monitoring, and debugging as things that we, as developers and engineers, we need to either get better at or start applying if we want to succeed on maintaining a distributed or a microservice architecture in production. And that was me. Thank you very much.